Welcome, everyone, to this session that forms part of Renew's newly expanded Sustainable House Day program. My name is Anna Cumming, and I'll be your MC for tonight. For a discussion that covers the benefits of using sustainable building materials and outlines some key factors to consider when making your choices. It's the third of 4 in our Sustainable Design 101 series, in which we're getting back to basics to help equip more people with the knowledge and confidence to build or renovate sustainably. If you missed our first 2 sessions, the recordings are now available to view on our YouTube channel. We have people tuned in from all over the country today from a wide variety of different traditional lands. I'm speaking from the traditional country of the Dja Dja Wurrung people in central Victoria, and I acknowledge them as the traditional owners of this land and pay my respects to elders past, present, and emerging. So I am the editor of Sanctuary Modern Green Homes magazine, published by Renew, the organiser of Sustainable House Day. I have a long-standing interest in sustainable, energy-efficient and comfortable homes that tread lightly on the earth. And I really love being part of the mission to inspire and educate people about the design strategies, materials, particularly tonight, and systems available to achieve them. In Sanctuary, we're always trying to cover all bases, providing deep dives into topics related to sustainable design, without assuming too much knowledge on the part of our readers. In this session, though, we'll be sticking with the fundamentals, exploring various characteristics of building materials, such as durability, health implications, recycling potential, breathability, to name just a few. We'll also examine the carbon cost of building and explore what the embodied energy of materials is all about and why it matters. I'm joined tonight by 4 super knowledgeable experts. Firstly, we have Elizabeth Wheeler, who designs and advises on residential dwellings, materials and products that don't cost the earth. She has a particular interest in small-scale renovation projects that transform both thermal performance and occupants' quality of life. Elizabeth's work is informed by her qualification in building design, Bachelor of Arts, and 3 decades of environmental and progressive social justice activism. Hi, Elizabeth. Welcome tonight.
Thanks.
Next up is architect Jane Court. Having commenced her architectural studies at the University of Melbourne and completing her degree at RMIT as part of the Spatial Information Architecture Laboratory, it's quite a mouthful, Jane co-founded the collaborative architecture practice Sibling in 2012, maintaining a strong culture of research and alternative practice and working across a wide range of building scales. She's now developing her own independent regenerative practice, Heliotope, through which her research and collaborations contribute to the development of low-carbon, climate-adaptive projects with a focus on construction industry waste streams, another super important topic related to building materials, and local production economies and ecosystems. Hi, Jane. Welcome.
Thank you.
We also have David Rochford, who is the Assistant Manager of the NATA's Operations Team at the Department of Climate Change, Energy, the Environment and Water. He has extensive experience in energy efficiency regulations and test standards for space and water heating and cooling appliances in both residential and commercial use. David's background is in applied science, and before embarking on a career in the Australian Public Service, he worked as a park ranger, wildlife researcher, community education ranger, and primary school teacher. And I realised I didn't check the pronunciation of your surname before I started, David. I hope I got that right.
Yep, Rochford, thanks.
Welcome, David.
Hi, everyone.
And finally, we're joined tonight by Grady Peterson. Grady's taken a lead role in the implementation of the 7-Star Homes program at Sustainability Victoria, which works with residential builders to increase industry capacity and capability for delivering energy efficient homes. Trained in architecture and energy efficient and sustainable building, he has a passion for sustainable construction techniques and materials and has experience living in alternative and off-grid dwellings. Hi, Grady. Okay, it's great to have you all here. Thank you very much for joining me, and let's get started. During our discussion tonight, I'll be putting viewers' questions to our panel. Thank you to everyone who submitted questions during the registration process. You can also put questions into Zoom's Q&A window at the bottom of your screen as we go, and we'll get to as many of them as we can. You can use the chat window to make general comments or to contact our behind-the-scenes team with any problems. Sustainable House Day is generously sponsored by NATA's Design for Place, Your Home, the Department of Environment, Land, Water and Planning, Sonnen, and Lighthouse Architecture and Science, and we thank them all for their support. This session is being recorded tonight. So, first question, let's dive in the deep end. The hundreds of material choices that need to be made for any new building or even renovation project can be completely overwhelming. But for many people, just leaving it to your designer or builder doesn't feel quite right, especially if you're keen to make your build as sustainable as possible. So, panel, what factors should people be considering to make sustainable material choices? Who wants to kick me off? And you'll all need to unmute yourselves.
I'm happy to start.
Go for it, Elizabeth.
I'll start because this whole question of materials specification is something that has been a real journey for me. So I thought I might just start by actually speaking about my own experience so that there's a bit of context. So I got into this whole thing of building design because my house, I had a house built for me by a really fabulous sustainable building company. And in the process of that, I got really interested in the whole thing of design and materials, and I got involved in selecting materials, and in that process, I got very I went down lots of rabbit holes basically, and so I ended up studying building design. Now I'm a designer and all of that's great. But I still come across a lot of people who, like me, get really torn, tear themselves up about what is the right material to use, looking for materials that tick all the boxes. And I guess over all of my experience, I've come to find that there are very few materials, possibly none, that tick all of the boxes when it comes to, to embodied energy, by which we mean the energy that's gone into the product all the way along its making, its manufacture, right back to the mining of the materials, etc. So, embodied energy, there's cost, obviously, there's, waste issues, there's your aesthetics, there's so many different issues. And at the end of the day, we all need to make some priorities and work out what are our own, what drives us. And there will be, I suppose what I'm wanting to say from the outset of this discussion is there will be compromises that all of you need to make when you're renovating or building.
Yeah, I think that's a really important point to make, Elizabeth. Thank you. That was sort of my my top line point as well. So there are lots of factors to consider when you're choosing any building material, and many of them require trade-offs. And sometimes that is sometimes an important part of that, quite often, is deciding what your own personal priorities are. Maybe zero maintenance is a very high priority for you, whereas for your neighbour, they might be very happy to refinish their external timber every 5 years or 10 years or whatever. So somebody might be very interested in getting materials as locally as possible, whereas other people might be happy with a material that's travelled further but costs less, for example. It just really does depend on personal priorities to a certain extent. And I guess what I would like to cover in this discussion is just in this first question rather is to just cover off a few of those considerations so that people are aware of what they are. You've mentioned a few already, Elizabeth. Would someone else like to jump in and talk about some others that that need to be taken into consideration when we're talking building materials, choosing building materials?
Sorry, David.
No, you go.
Go on, Jane.
Okay, I was just going to say, I think part of the reason I was really keen to develop a more deliberate architectural practice was just so that I could develop a much more local palette. Mm-hmm. And I think after COVID and all of the supply issues, as well as, I guess just being able to assess the specific issues relating to each material and all of the assessment, all of the ways that you assess each material, just simplifying that palette right down to a local concern has been really useful. But I know that that's not always the way to go, but it does it does mean that maybe a much more limited local palette is much easier to deal with than a huge complex kind of array of different materials. So I think the first question is even to ask whether you really need that particular material at all. That's probably step number one. Yeah.
Yeah.
And just trying to keep it as simple as possible would be my advice.
That's akin to the general sustainable design advice of, you know, the most sustainable first step is to build less house. It applies to building materials too, doesn't it? Do you really need the material? Can you build smaller or simpler so that you require less of it?
Yeah.
Yeah. David, what were you going to say?
Yeah, I was going to add that you know, one of the ones I deal with in particular in matters, obviously, and I have a limited perspective on this in many ways in my work. It's the excuse me, the performance of the material, and that's where you know, the Natter software if the performance is something you're really interested in and looking at the performance of different materials, if you work with a Natter's assessor, preferably an accredited one, you know, they can help you show the performance outcomes of different material choices. And the other thing I was going to give a plug early on is the rest of my team is, or the team that I work in, they're responsible for the Your Home resource, and that's both a book and a free website. So there's a lot of detail in that for people, and it's a trusted source. It's written by government. We farm it out to independent experts, so there's, you know, no one trying to sell you anything there or sell you what they sell. It's all independent advice, and we'll run through those pros and cons because of all of them. Because as Elizabeth was saying, and sort of Jane added to, there's no perfect material. There are the good things and the drawbacks of all of those materials. So and it can be just to acknowledge, it can be really overwhelming too if you're trying to research all of that. So I do like Jane's advice about asking those hard questions first up. Do you really need that? And can you get it locally? So, and that's going to help limit you down to some of the maybe a more manageable set of choices as well.
Yeah. But I think it also means that maybe your building sort of talks of this place more strongly as well, which I think is really important to connect back to where we live and our local social, cultural and environmental ecosystems is really important.
So we've talked about the local availability of materials. That's one factor. David's talked about the performance. That's, of course, a very important factor when you're choosing materials. You know, is it fit for purpose? Is it going to do what you want it to do? Is it going to keep, if it's cladding, is it going to keep the rain out of your house? And different materials also can provide thermal and energy efficiency benefits to your build, particularly thermal mass materials, insulation materials. Obviously provide insulation, so it needs to what it will contribute positively to your build is important to consider, and sometimes that's a trade-off with the embodied energy involved in the manufacture and transport of the material, which we'll dig into a little bit more down the track a little. What other factors are there to consider? I mentioned low maintenance before. Maintenance requirements is another factor. Give me some others, panel.
Well, one of the other big ones is the familiarity of the material to the builder. And so, and it's a little bit of a chicken and egg thing, because obviously, you know, you want to choose, you might want to choose a builder who is very familiar with working with, you know, a slightly more unconventional material. But I suppose for most people who are building, they're going to be building with a builder who has come to them via a personal recommendation, and often those builders are not necessarily going to be very familiar with you know, some of the more bespoke materials. So having a material, and that translates into cost, really. Usually at the end of the day, that makes a difference to how much the builder is going to charge you to work with that material. So the familiarity with the builder, and also the ease of building. building, the ease of construction. So it's not just about a builder being familiar, it's also a builder being able to complete your project in a timely fashion. And so some materials lend themselves more to that than others.
Especially in this current climate, supply chain issues, availability of materials too. You might actually make a decision of this material over that material based on when you can get it, or when your builder can get it.
Yeah.
I'm sorry.
Go on, no, go Jane.
I would also, I think time is really really important to consider as well. So that sort of ties back into the operational versus embedded carbon calculation as well, in that you can probably justify a material which has more embedded carbon if it's going to last longer in the project. Yeah. So you really, I think, having a handle on how long you intend the project to last for, what kind of warranties each of the material has, and then how often they each need to be replaced. I know it gets a little bit complicated, but it starts to feed into material choices and also maintenance regimes and things like that. So just having a bit of a meta kind of think about, how those materials each play out over time is a really good idea.
Yeah, absolutely. And things like maintenance can definitely link into the cost calculation as well. I mean, especially if you have a two-story house with a cladding material on the top story that requires regular maintenance, you're going to be paying for scaffolding every however many years to do that, which is a non-negligible cost just in itself. So I hope that our listeners are starting to understand how all these different considerations link in with each other, and it is really a trade-off in many cases. So we've covered logistics and availability, familiarity. Cost is a factor, of course, for just about every single person who's undertaking a project, and it may well be a big factor in the trade-offs that you need to make. Aesthetics is, of course, a thing as well. You want your house to be joyful and beautiful and lovely to live in for you, and that's not to be dismissed. Yeah. And also, actually, one topic that we haven't mentioned yet that's on my list that I wanted to cover is health implications and toxicity of materials. Jane, I know that you're doing a bit of study that touches on that area at the moment. Do you want to talk a little bit about that?
Yeah. So I'm currently becoming Living Building Challenge accredited, and so I don't know how familiar everyone is with the Living Building Challenge, but it's an incredibly rigorous certification process that buildings go through. There's not too many accredited buildings in Australia at this point. So like a lot of accreditation programs, they're usually geared to the Northern Hemisphere. So it's new space. But it's really exciting. But I guess I brought that up just because they run a material certification program as well, which specifically deals with individual materials. So the way it works is that manufacturers and suppliers do actually pay for their material to be accredited, but it's an independent accreditation, and it's called Declare. I can share the link to the database for Declare products that might be available in Australia, but it's just a really handy certification because it tells you where the product is made, how it can be reused. It goes through all of the red list chemicals, so whether it's got any toxic chemicals in it, and yeah, actually a whole lot of really, how much embodied carbon it has. It's just a really handy label. It's just not that many materials in Australia necessarily have achieved it yet, but definitely look out for it.
Sounds like a path that we should be encouraging our manufacturers to go down.
Exactly. Actually, advocacy is a huge thing. So it's always worth asking manufacturers what their accreditations are, just to keep
more people ask,
from the bottom.
It'll be on the manufacturer's radar, absolutely. And the red list that Jane mentions, I think even if you're not planning to pursue anything any part of the Living Building Challenge for your design or anything like that, the red list, which is a list of chemicals, like Jane said, that are banned in Living Building Challenge materials, is a really interesting thing to check out, just to because it gives you a good indication of things that you have, components in building materials that you might want to avoid. Thanks, Jane, for that little overview. So somebody in the chat has just asked, please just as an aside, put your questions in the Q&A as opposed to the chat, but I'm going to just address this one because it leads in beautifully to my next question. Leslie has asked, how does green concrete and a raised timber floor stack up? And what else can be used for thermal mass? So I wanted to talk about concrete because it is a ubiquitous building material included in very many home builds and renos. It's both sustainable and standard home builds. Can you guys please explain briefly, and the reason that I want to talk about it is because it really does have very stark pros and very stark cons. And so can you explain a little bit about that for me, and what options are there for more sustainable concrete choices or alternative thermal mass options? Grady, do you want to have a go at that? We haven't heard from you yet.
Yeah, I guess so. So in terms of concrete, it is pretty limited in sustainable options. You can target, concrete with a higher mix of fly ash or reduced cement content, things like that. To address the part of your question,
do you want to just back up a little bit and explain why that's an issue? Well, what is it about concrete that's not so great, and what is it why do people love it? Or do you want to, feel free to throw to someone else if you prefer.
Yeah, I can. Why do people love it? As a huge fan of architect, I love concrete in buildings, but it is really, really carbon intensive to produce the cement, and it is a difficult material. It also has some issues around circularity. It can be hard to recycle, can be a bit limited in terms of the amount of recycled content that can be included in concrete. Although there's a lot of research and a lot of funding out at the moment trying to work on projects that can increase that. So Sustainability Victoria has recently funded a few projects looking at increasing or replacing some of the sand content in concrete with recycled glass products, and working out the processes to get that certified, which it has been for roads now, but not as much for construction. So there's a lot of things that you do have to sort of weigh up to address the sort of thermal mass. How does it stack up versus a raised, timber floor? Really dependent on your climate zone, whether thermal mass will even be hugely beneficial to your house or not. And where you need to include that thermal mass, you can have a raised timber floor and some thermal mass in your home, and avoid concrete if you're looking for that pathway. Otherwise, if you aren't able to avoid the concrete, you're having a slab anyway. Try and get those lower emissions cements, which are available, albeit a little bit more expensive.
Certainly from the performance perspective, we see even up north in the tropics, like in Darwin, most builders are choosing the easiest way to get those energy efficiency gains is to build concrete slab on ground. And it's it's not only the thermal mass of the slab, but it's that coupling to the ground from the thermal physics perspective is that generally suspended floors just cannot compete with the performance advantages of a slab coupled to the ground, because the ground is always a fairly set temperature, and even if you're in Darwin, it's probably still 20 degrees or so, and the air, any sort of air that gets under your floor is going to generally be a lot hotter than that. So yeah, that's what builders like to do is they tend to go for the easiest winner in terms of meeting the energy efficiency requirements of the code, and that's why Darwin has sort of been transformed from those post-Cyclone Tracy houses that were all suspended timber floors to when the building code came in, and thermal modelling sort of became a big part of that process of showing whether you comply or not, and they all changed to generally single story coupled to the ground to reap that benefit. So yeah, so there are benefits to it, but as Grady was saying, there's also those negatives.
Yeah, the benefits are.
Without getting too technical, I think it's worth sort of digging in a little bit more around the just for people to understand the differences between the regular concrete that we have, the green concrete. So when we have a green concrete, we add in a lot more recycled aggregate and fly ash to substitute for the cement. So that's the process. And then there are now products coming on the market, not just in terms of concrete, also plasterboard, quite a number of others, where they're offsetting the emissions as well. So now there's a whole lot of stuff we can't even go there on offsetting programs, and they have their problems for sure. But I just recently participated in a competition that was looking at reducing our embodied energy and reducing our emissions in the buildings that we were designing. This was for a Melbourne house, and I had a slab size, which is 165 square meters, which is a relatively small for a new house. When I used the green concrete, we saved 9.2 tons of CO2 emissions by using that green concrete. And then by using a carbon offset, that offset another 3.2 tons of carbon dioxide. So we're talking about very large quantities of carbon dioxide going into the atmosphere. And if we can avoid it by spending, usually it's sort of $1,000 to $3,000 more, that makes a really quite significant difference. But what I did want to say is that I also, in that process, looked at what if I had built my house with a timber floor instead of a concrete floor. Mm-hmm. And so this is where design and material selection are really, really connected, because we need to, and as David was talking about, with our NatHERS ratings, a lot of the time, if you're doing a renovation or an extension or a new build, you'll need to do have your house energy rated. And that's where you get your building design, your energy rater to say, what if we did it with timber? What would be the difference there? And most people don't have at their disposal the kind of carbon footprint data that I had for that project. But what I found was ultimately that there was actually, my star rating dropped quite a bit, but the actual, in terms of the emissions overall, it would have been better to build with a timber floor than to build with a concrete floor. So it's not always just about, it's a dynamic process, I suppose, in which you've really got to dig in and say, what if? And that's what your building designer or builder probably won't do unless you've specifically chosen them or you really push them.
Yeah, trade-offs again. Yeah, absolutely. And I mean, concrete has lots of other benefits as well. It's very durable. For example, it'll last an awful long time. On the other hand, it's not easy to reuse, or there are recycling options, but they're not sort of extensive. So what and I realize we've been talking about thermal mass, and I just want to quickly explain to people, in case they're not familiar with that term, that that refers to a material that has quite a capacity to absorb heat. And in a good sustainable design, a thermal mass element like concrete or bricks or other masonry kind of materials can be positioned in a place where it'll get the direct sun through windows, store up heat during the day, and then radiate it at night, and it works the opposite way in summer. So it's basically a way that you can design your house and choose your materials such that the house will regulate its own temperature passively without needing to put in active heating and cooling to quite the same degree. So that's why it saves energy and money and when it's in a well-designed house, reduce the operational energy required for that house at the cost, in the concrete's case, of quite a high embodied energy bill. So what other alternatives are there for achieving those thermal mass benefits without using concrete?
I guess ultimately it's really, really easy to tip the scale with thermal mass in terms of that embodied carbon versus the operational carbon. And you could end up worse off. You might be having to put a bit more energy into your home to keep it comfortable. But in the long run, you know, that not having that embodied carbon up front can be beneficial. So if you were including, for example, an internal brick wall or doing a reverse brick veneer purely for that thermal mass, you could really try and use some recycled brick content, or go for a stone or something like that, rather than new virgin products or concrete tile, things like that are quite emissions intensive. Embodied carbon in thermal mass can really tip that scale and make it impossible to get a zero emissions sort of building across the life cycle.
It's also worth thinking about the fact that high mass materials also are heavy, and so they have to be held up. So then you start to look at needing strip footings, for example, at least. So we're back into concrete land, or steel beams. So, and once again, steel is also very high in embodied energy. So sometimes the things that you think might help to environmentally in terms of mass still end up, costing. There's a net environmental loss.
What about hempcrete, rammed earth, mud brick?
Some of which still need your concrete footings, most of which do. But yes, they are great. They're once again, they're bespoke, I suppose. You might find it hard to find a builder who is willing to work with them, but such a beautiful organic feel to your build, and that's a really great thing. In terms of a lot of those projects, they're particularly well suited to owner builders. So because a lot of them, they're very slow to install. You have to put them in slowly. They're incredibly weather dependent a lot of the time. So if you're using them as external walls, then you have to be able to cover them up and protect them from weather during the process of putting them in and then curing. The other thing is that sometimes you need thicker studs as well, so you need your timber budget is going to go up quite a lot as well. So and the other thing to say is that if you're putting them, they take up so much room as well. So that means your house gets bigger as a consequence, which makes
that's true.
In the urban environments that I work in, that's quite a
that's
challenge.
definitely a consideration, isn't it?
Yeah. So
anybody else have thoughts on alternatives to concrete for thermal mass like that?
Water is a good one if you can use it, but is inherently risky for obvious reasons.
Yes, and it's a little bit of a traumatic thing to suggest right now, given that so much of the country is currently under floodwaters, or has been at some other point this year. So, but yes, it's all jokes aside, it's a very good thermal mass material. From a scientific point of view, and has been incorporated successfully in projects that I'm aware of, but is trickier.
I know of a woman whose father had a whole lot of wine that had gone off, and she had to reinforce her footings to do this. So it's not the kind of thing you can just go, oh, I'll chuck it in at the last minute, because when to get that kind of to get the kind of mass we're talking about, we are talking about heavy, quite a lot of weight, unless we're talking about things like phase change materials, which are particularly, which are usually an oil-based product that responds to changes in heat and works like thermal mass, but is much smaller, but incredibly expensive.
And so cool. David, I think you might have had a couple of things to add about phase change materials. Do you want to just introduce, explain to our audience what phase change materials are and where they might be particularly useful?
Oh yeah, look, and I'm no expert by any means, and certainly in Natta's tools we don't really cover them either. So they're quite advanced and not rarely rarely used as far as I'm aware. But yeah, essentially, as Elizabeth was saying, that it's some sort of material that will change phase from a liquid to a solid or something like that, and can basically do the job of concrete in terms of what Anna was talking about, absorbing large amounts of heat and then slowly releasing it, so that that sort of up and down fluctuation of nighttime, daytime temperatures can be ameliorated by this phase change material absorbing some of those peaks and then releasing it and filling in some of those troughs overnight. So yeah, there are a number of them, but I'm no expert on what they are, I'm afraid.
My understanding is that the main advantage that they have over traditional thermal mass materials is that they are much more compact. So
yeah, exactly. Their heat capacitance for their volume is much greater than concrete. So as you're saying, a small amount of this material can perform the same amount of heat absorption and then releases a large amount of concrete.
Grady, you look like you might have had something to say about that.
I'm not an expert on phase change materials at all, to be honest. But,
might be.
Yeah, I can see a few things popping up with questions around like mud brick and things like that, and stone, and they are really, really good options if you are trying to get something, local. If you're lucky enough to be building on a property where you can source the mud or the stone yourself, you can save a lot of money and in terms of sourcing your own stone and things like that by going really local. Just have to be careful. A lot of the mud brick homes we see around and you might see or go and stay in on an Airbnb or something like that have been built prior to energy efficiency standards in construction codes. And although they are quite comfortable and can be quite comfortable to live in, to be code compliant, particularly for external walls, there's a requirement, for additional insulation. So you're not necessarily going to have the internal, external mud brick look throughout your whole home. There's some design things you can do to hide where you're putting the insulation and things like that. But
we're actually working with the Mud Brick Association at the moment in the Natters tool to incorporate some new what do they call it, like cobs kind of mixtures with like straw bale and that sort of thing in the cement. So essentially some lower density things that have a better R value as well as those thermal mass properties. So yeah, we're just working on that now, and hopefully early next year we'll be able to release some new materials into the Natters tools that can cover different density mud bricks. At the moment we're very limited, and therefore the choices for mud brick builders to, as you were saying, Grady, to achieve compliance are quite limited. But yeah, with this it might actually help in terms of that added insulation that you were explaining. So that's one to look out. But I think, as it was mentioned before, very bespoke still. This is not something that works particularly well in suburbia, but if you've got your own block, yeah, fantastic, give it a go.
I did have another thing to add about thermal mass. You can sort of artificially get the benefit from thermal mass in a home where you might not be getting the sun heating up the slab, but if you did have some internal brick walls or similar and efficient electric appliances with PV, during the middle of the day where you're using, you're producing energy from that solar, you can cool or heat your house, let the mass absorb that energy, and once the sun goes down, you're not producing solar anymore. Switch off those systems and you'll get that same kind of slow release of the cool or the warmth from that mass. And that's a good way to kind of use your home as a bit of a thermal battery. Sure, we're using energy and appliances and things, but it's a good way to, increase your self-consumption of solar and kind of sort of manipulate your building to be a bit of a battery.
That's a great
Let's
idea.
take a tiny detour down the hempcrete road while we're talking about thermal mass materials, which hempcrete is in a way. We've had a question from Rita who asks, we hear so much about the positives of hemp building. What are the negatives? And so I'm going to throw to Elizabeth. Could you just quickly, for the people who don't know about hempcrete or hemp building, hemp masonry, what the benefits are, the positives are, could you very quickly enumerate them for us? And I know you've got some things to say about the negatives too, although I understand that you are a big fan of it, as am I.
Look, I think I probably touched on the negatives before, really. So hempcrete is basically a process by which you grow hemp. So it takes up carbon dioxide as it's growing, and then it gets.
It's a very fast growing crop.
So
and it's a very fast growing crop.
And grown now in Australia. It wasn't earlier on, but it is now. It's available from locally produced. Gets chopped up into a rough material, and then you pack that, mix it with a slurry, pack it into around a frame usually, and then you render it. And it provides you with really great R value, which is your insulative value, and also has some thermal. It's also thermally massive. I suppose, in addition to the things I mentioned earlier around, the bespokeness of it, I think probably the cost is also a really significant issue for a lot of people, and the fact that at the moment in Australia there aren't many options on the market for hemp blocks, for example. So it's mostly non-structural. So you need to build your structural frame, and then you use the hemp around that. So it is a great option for owner builders, but probably not something you're going to use in a but you could it's great for something like a central wall of a house, and that's a really good and easy application for it. And there's quite a lot of builders around who have had a go with that in that context. It's when you want to start to use it for your external walls and expose it to weather and all of those kind of other complexities that it becomes a little bit more difficult.
Yeah. It's much lighter weight to work with than, say, rammed earth as well, which made in a similar way with formwork and so on, but much lighter weight. So yeah, even easier for owner builders, I think. It seems to me like hempcrete or hemp masonry is a material that's going to continue to take off as it gets more available and therefore cheaper and available in more different forms and so forth. Someone in the chat's just asked about the R values of hemp, and I guess the answer is probably it depends on the thickness of the wall and so forth. David, do you have any insight into that from a Natta's point of view?
We do cover it in Natta's, and I know the R value is pretty damn good, and I was just having a quick look at the Your Home website because I know it's there, or from memory it's there.
For like a 30 centimetre ruler, kind of a 30 centimetre wall, I think it's in the lower 3 range.
4.25
for 30 centimetres.
30 centimetres.
30 centimetre. So a 300 mil wall is R4.25.
But a thick wall.
but I guess so to bring that into some comparison, like usually we'll have an R2.7 wall, and that will be that's usually a 90 mil stud and a 10 mils of plaster on one side and whatever your external cladding is on the other. So to get something comparable, you're looking at a 200 mil wall, so you're almost doubling the size of your wall to get that.
So if you actually did a double stud with double insulation, you would get get a better R value than or similar R value to a 30 centimetre hempcrete wall.
Yes, but much more, but more probably more embodied energy, although it probably depends on what material you're using as insulation, and it also depends on what, you know, how far your hemp is coming. And the lime render, for example, is imported, and you know, so there's a lot of other things at play.
Trade-offs
As
again.
always.
And it's not quite as maybe you covered that, Elizabeth, but it's not quite as strong for its, you know, as concrete, for instance. So yeah, there are those implications there. You may have to be including other stuff to sort of reinforce and hold up roofs and things like that.
Somebody's mentioned about the hempcrete in bushfire risk areas, and it is really great for that. So it's really quite resistant to fire. So I suppose for people who are, you know, one of the things about building in high bushfire risk areas is that you can end up with buildings that look very factory-like, or very kind of, you know, inorganic, just because of the nature of the materials that we need to use to prevent bushfires. So hemp is a great option there, because it just has that more organic feel that, you know, we as biophilic people, we can appreciate that.
And it is quite breathable.
Yep.
Yeah,
I understand.
it is.
In fact, continues to sequester carbon from the atmosphere once it's in position as a wall.
Yeah.
So
Zero toxicity. It's pretty cool.
Yeah, it is pretty cool. What about Hebel? Which I think is aerated concrete, is that right?
Mm-hmm.
Comes in block form.
Autoclaved aerated concrete.
What does autoclaved mean? That the way it's made?
Yeah, so it'd be at great temperature, I imagine. So it's probably pretty carbon intensive, but I'm not an expert on that.
Yeah.
But yeah, lighter, still with good strength. No doubt with the aeration would have better R values than solid concrete. So that insulating properties. But yeah, light and kind of quite easy to work with, comes in blocks.
Probably not terrific from a body energy point of view.
I suspect not.
So I'm going to push on to our next big building material topic, which is timber. Another material used in just about every build. It's renewable, but also presents really knotty problems related to unsustainable forestry and sourcing. How best to choose timber for your build? Who wants to go first? Jane, do you want to go first?
Okay. It is a very fraught process. There's obviously the Forest Stewardship Council certification, which is generally very good. They do have different levels of certifications. They're just double checking what exactly they're talking about. Unfortunately, timber produced in Victoria isn't certified, but it probably is better than non-certified timber from another country where the production or labour methodology and ethical supply chains and things like that, the working conditions are much worse. Yeah, so the standard here would be higher. But yeah, I mean, obviously, if you can find salvage timber, that's the best option. But yeah, that can be tricky as well. I know that there were some logs being pulled out of hydro dams in Tasmania, but yeah, I think it's just timber is just another fraught issue, especially now that so much of it burned down in bushfires as well. But yeah, I think just have to do lots of research. There are some timber farms that are producing local timber as well, but they're also expensive and hard to source. So it's just something you have to do a lot of homework on, I guess.
I think that one of the things that this highlights for me, the whole timber dilemma highlights the importance of keeping your house small.
Yeah.
Because it just means you use less because there really is, you know, as much as, you know, if I would love to have had, you know, $100 for every time somebody has said to me that they're planning to use a whole lot of, you know, they want to mostly use recycled timber in their house and it's a beautiful ideal, but it's actually, as Jane says, it's, you know, it's quite expensive to do that. Plantation pine is generally very problematic. There's we're talking about monoculture agriculture. We're talking about quite a lot of chemical runoff. We're talking about erosion, soil erosion of logging roads and things like that. So even, you know, often people might say, oh, I don't want to use native forest timber, but, you know, I'm okay with pine. Well, pine has its own huge set of issues as well. So trying to reduce the footprint of our houses, keeping them as small as possible, means that we, using a bit of whatever we can in terms of, definitely in terms of the FSC certification. I think this is probably a good time to also flag that, I suppose, as sustainability has become more of a buzzword, greenwash has become more and more, you know, has proliferated basically. And so no more than in the timber industry is absolutely rife with it. So you will see a lot of places that tout their what the PEFC or AFS as some sort of indication that their timber practices, their logging practices are sustainable. All timber activists would say that those standards are not worth the paper they're written on. So from my perspective, I would always choose the FSC if it's available. And even then you have to be careful, because sometimes people claim FSC certification when their certification is out of date. But the other thing to say is that that you know, sometimes you might find that there's a timber product that it only has those certifications, and you know, it's still probably better to use that than to use a steel cladding, for example. So you know, and that comes back to, as Anna said at the beginning, sometimes it's about what is your personal priority, or you know, the thing that worries you most.
Yeah. Thank you, Mark, in the chat for posting the link to the Mullum Creek Timber Guide. That is a really useful guide. Mullum Creek is an eco-development in the suburbs of Melbourne, and they have very rigorous design guidelines and have put together a timber guide, which is actually a really robust document, and it's one of my go-tos. We also published an article in Sanctuary a couple of years back called A Knotty Issue on responsible sourcing of timber. And the too long didn't read summary of that article is that there's the hierarchy of choice that we recommend really is recycled if you can, salvaged timber or ethical agroforestry sourced timber if you can. Ceres Fairwood in Melbourne is a great operation that operates in that space. Salvaged and ethical agroforestry space. If anyone knows of similar operations elsewhere in Australia, please feel free to put the links in the chat, because I personally would love to hear about them. Then after that, like Australian plantation grown in well-managed forests, sustainably managed plantations, if that's, you know, to the extent that that's a thing. And then way down the bottom of the list, anything overseas. Anything comes from overseas, pretty much.
Yeah, I think Living Building does publish a map of like a general guide to how ethical or sustainable the forestry industry is for a range of different countries around the world. But obviously,
that would also be handy to check out.
But yeah, because some countries you definitely want to steer clear of.
And if you're gonna opt for FSC certified timber, try to make it FSC certified Australian timber as opposed to FSC certified overseas timber, because it's much harder to ascertain whether the certification process has been rigorous. Yeah.
One other quick thing to say on timber maybe is just looking at the efficiency of the cut. So radial sawn is going to give you a much stronger and more efficient use of the timber than cutting straight through the crown. Yeah.
And designing your house, if you can, so that it is its dimensions are such that it matches what's available. You know, timber
Standard
members
sizes.
and other materials as well. So to minimise waste.
Yeah.
There's a question from Sarah that's come in that touches on this topic. In the current market, where timbers and steel are priced at just sky high at the moment, what are the smart or alternative savings options, material options? That wasn't very coherent, but yeah. What can people use instead to avoid those super high costs of materials right now? Is there a quick answer to that?
Nothing.
Nothing.
Look, I work in
Yeah.
a very budget space. Most of my clients are people who are really wanting to spend not very much at all on their buildings. I work very hard to avoid using steel. That's the thing that, from a cost point of view, that's really that's the big one. I can't go. It's just about keeping your building small. Once again, really, you can't get much cheaper than a stick build with MGP10 pine, really.
Even with the current price hikes.
Even with the current prices. It comes down to design questions. So it's things like minimizing the spans, you know. So if you can just use MGP10, you don't need to go to LVLs, then that
can you just unpack
Yes.
those acronyms, please?
So LVLs is a laminated veneer lumber. So it's when we to get bigger spans, because trees max out at a certain size, and it's very hard to get really big, long members. Then we engineer them, and so they can cost a bit, and they're heavier to move around and carry around. So from a labor perspective as well, it's better if you can minimize the kind of sizes of your openings, minimize the spans, and that also usually means you'll have a smaller house. And also it's another, we tend to really overglaze our houses in Australia, and if the wider your opening, the bigger your lintels are going to need to be. So if you reduce the size of your opening, you're going to do better from a thermal performance perspective, and you're also not going to need that whopping great big lintel. Because the lintel, it's not just about the paying for the lintel, it's also that's half, you get half insulation all the way along that lintel. So
because the lintel takes up half the depth of your wall,
That's
leaving less for insulation. Yeah. That's a really good summary. Would anybody else like to comment on timber before we move on?
I guess something that you can do to reduce the waste impact and cost of timber is go to a quality modular builder who has, I say quality because there's probably a few different types of modular builders, but the builders that have tidied their supply chains down to really accurate cuts. They reuse all of the offcuts in the next build. Everything's done in a factory, so the waste is really minimized. And there's some really reputable modular builders who are putting a lot of thought into reducing all that wasted timber on your construction site. You're paying for all those little bits that get thrown into the skip. If you go for someone who's reducing all of that waste, you can also reduce the cost.
Yeah.
And the amount of material, perfectly good material, sent to landfill.
The other thing that we haven't talked about there is structural insulated panels. So that's not usually a cheaper option, but it is sort of worth putting out there. Although very few, I don't usually work in that space, mostly because they're almost always filled with polystyrene. There's a few people around who will who do other SIPs. That's what the acronym is. But most of them are polystyrene, but they are also an option. That we should throw in the mix.
That's true. Yeah, so they're kind of like prefabricated wall and roof panels.
They're like a sandwich, basically.
Yeah.
So they're usually, cladding on one side, your insulative material on the other, and a skin on the other side. And but they actually can
They're structural.
They can bear load.
So in that sense, they're slightly different from the prefabricated options that come as panels as opposed to three-dimensional modular. Which are not necessarily structural. But anyway, now we're probably going down a rabbit hole. But thanks for mentioning SIPs, Elizabeth, because they do come into the building materials category. So I wanted to talk about windows. Usually one of the biggest ticket items in any build usually. The range of frame and glazing options can be a bit mind-boggling. What do people need to know about choosing windows?
Well, there's a lot.
There is a lot.
Yeah, I mean, even just getting back to their relationship with the thermal mass is really important. So obviously they're letting in heat, letting out heat. So how do you add layers or shading devices to them to be able to control that as well? And then the thermal bridging between the inside and the outside. So using something like timber is going to be very effective to stop that heat loss compared to something like aluminium, obviously.
For the frames.
Yeah.
Yep.
You can do a combination, and it can get expensive, obviously, but I suppose timber's ideal. Yeah.
From a thermal point of view, higher maintenance though.
And from that thermal perspective, I suppose there's two aspects, the key bits of data that people will see when they're looking at windows, and that's one is how much solar heat gain is let through the glass. So how much solar or heat radiation comes from the direct sun, and that's sort of the heat that you can feel from the sun on your cheek. That's the solar heat gain coefficient, and that's one of the key numbers you'll see on a window. And it's a number between 0 and 1 in theory. So the higher the solar heat gain coefficient, the more heat it lets through. And
whether that's a good thing or a bad thing depends on your climate.
Absolutely, and the side of the house and all of that. And the other key bit of data you see with a window is it's called its U value, and that's the insulation. Think of it, it's essentially the inverse of the R value of your ceiling insulation. So the lower the U value, the more insulation that window provides against the movement of heat from. So, if it's 40 degrees outside, there's no sun hitting your window, but how much of that 40-degree heat is transferring through the glass into your air-conditioned house? And, and in winter, how much of that heat from your heater is transferring through the glass out? So a product, say, triple glazed, that's going to have a very low U value, especially if it has a good thermally broken frame, and a single pane of glass, a single thin pane of glass with aluminium frame that's not thermally broken, as Jane was sort of talking about there, very poor performer. Well, that's where you'll see U values sort of reaching around 6 or more, which means heat just travels freely from one side to the other. So they're the two, from a technical perspective, they're the two things you're looking at. And as was mentioned, it really depends on your climate and other things about what you want in that mix. And to some extent they're a bit mutually exclusive. So if you want something with a really great U value, like 3 panes of glass, those 3 panes of glass aren't going to let much winter sun through in terms of that solar radiation. So you'll find that fantastically low U value is also going to have quite a low SHGC value, because a lot of that solar radiation just gets reflected by 3 layers of glass and not much makes it through. So on a winter's day, if you're standing next to that window, you know, you're not feeling that real warmth on your cheek because it's just getting reflected.
Impeding the passive solar design performance of your house.
Yeah, but U value generally wins out in terms of, you know, the sun's not always shining and overnight it's just not there. So the better U value tends to work better if you're trying to keep your house conditioned. Whereas you might, if you're trying to go for more of a sort of a what do you call it, a tropical design with lots of airflow, the triple glaze probably isn't the go because it's just going to trap heat. So yeah, very complex, and that's just some of the complexity there to think
and there is a rating scheme for windows. Is that what you're about to talk about, Grady?
No, but go ahead and I'll just add my comment after.
I was just going to say that there's a rating scheme for windows called WERS, Window Energy Rating Scheme, which rates the window as an overall unit, so including the frames. And so that can be a really great thing to look up to check what the expected performance of any particular window that you're thinking about putting in is.
Yeah, it has a star rating too, so it breaks it straight up into 3 sort of basic climates: hot, cold, and intermediate, and it tries to rate those windows with stars to sort of give you that indication of whether it's a good window for the tropics or a good window for Tasmania.
What were you going to say, Grady?
Well, I was going to say windows is a really good reason why you should engage your thermal performance assessor early on in the design process. They'll have a really, really good idea of the U values and SHGCs that you should be targeting in the area that you're building the home. They'll also have a pretty good a pretty good idea of some of the suppliers that are working in that area. They are an energy efficiency sort of knowledge, they don't just do your star
Knowledge
ratings.
bank.
Maybe in the past they have, but they're a huge source of knowledge, and they will know what you should be targeting, what those trade-offs might mean. And it's very hard to give advice on windows to a national audience because what you're targeting varies hugely depending on climate.
And even
it's not just about
it's
not just about the window product that you choose either. It's about the size of the windows and the way that the direction that they're facing and the shading that you incorporate and various other design decisions. Elizabeth?
Yeah, I was just going to say that most window manufacturers worth their salt will be able to tell you the U value and the SHGC of your windows. And that's something that's important to, when you have a NATERS rating, that will be specified somewhere on your working drawings. And so there's an obligation to at least deliver those as the maximum. And it's really good to make sure that you look into that and make sure that you working with your thermal performance assessor, see what happens if you change out the thermal performance of the window a bit. And sometimes that can be making it, what if we make it bigger, or what if we make it smaller? What if we change where the coatings are? There's a whole range of different things. Those are the things that often, if you're just doing your energy rating at the end of your project, and in a very mechanistic, we need to get to 6 stars, now 7 stars kind of way, then that won't, those kind of experiments won't be done. So really push the envelope there. It's worth it, because it can make a really big difference to your energy bills.
So let's talk about different frames.
Mm-hmm.
So there's timber, obviously, which has previous discussion about sustainability of timber, but it is an excellent thermal material for window frames, but does require more maintenance. And there's aluminium, steel, and UPVC. I think that pretty much covers. And
fiberglass.
And
fiberglass as well. Yeah, there's a bit of fiberglass.
Fiberglass.
What? So
that. Tell us more.
Oh yeah, look, it's I'm not sure if it's locally manufactured, but there is fiberglass window frames available, and it has similar thermal properties to UPVC.
Okay.
So, which is on the better end of the insulation. The worst is aluminium, and probably then I'm guessing would be
Worst
steel.
why, David?
And in terms of the heat transfer, the U value that you're going to get with aluminium, now, you can get thermally broken aluminium, so it's sort of an inside piece and an outside piece with a rubber seal sort of typically in the middle, so that the heat can't just travel from one side to the other. It's actually broken by that rubber seal. And in which case they're great. But yeah, fiberglass, it's available, but it's not common.
Can I just say, I'll just make a comment on that, on the aluminium windows, because I actually use them a lot in my projects, because timber is one of my, especially in Victoria, where timber, the timber options are really not good. And the only timber frame that is a really viable from an environmental point of view is called a Accoya, and it's a treated timber, and it has cradle to grave certification, and it's actually a treated plantation pine. It gets shipped all around the world in that process, but it is actually still comes out ahead environmentally, and they've done life cycle assessments on that. But it is more expensive, and it's of the order of, usually it's like probably 1.5 times more expensive than what my clients would usually pay. So we often use aluminium, and I target a U value for myself. That's where I target a U value of 3 and a solar heat gain coefficient of between 0.4 and 0.5. So, and that delivers me great results from a thermal performance perspective. And the reason I bang on about this a bit is people get very stuck on the idea of whether a window is thermally broken or not. And often the thermally broken windows can be very, very expensive, or a lot more expensive.
Definitely.
So, and I'm happy to if especially David, Grady, because you do the NATO stuff too, if you have alternate views on this, but my research seems to suggest that the U value is more important than a thermal break per se. So if I've got a product that has a good decent U value, then that is what I will go for, and I'm not going to get too stuck on whether, providing the SHGC is enough, I'm not going to get too stuck on whether it has a thermal break or not.
And aluminium's eminently recyclable as well, which is
very high embodied energy especially in Australia, because our smelter is fueled by brown coal. So there's a whole lot of stuff to do with that, obviously. But from a maintenance point of view, from a longevity point of view, from the fact that it doesn't bend or warp, so you'll have a very consistent thermal performance and no draftiness, there's a lot to recommend it.
So it's probably important to note that the U value is the glass and the frame as well.
Yep.
So again, it goes back to that trade-off and balancing act. So you can avoid the low E coatings, or maybe have just standard air-filled double glaze instead of going to argon by having a better frame. Through the 7-star program, sorry, I can't talk properly. Through the 7-star homes program at Sustainability Victoria, I do lots and lots of engagement with, some of the biggest builders nationally. And with the move from 6 to 7 stars, we are going to see an increase to the need for thermally broken aluminium frames, and better glazing in the volume construction sector, which is such good news, because with demand, means that the cost of these things will be reduced. Those big builders, your Metricons, are putting pressure on their suppliers to increase the standard of windows available to them. And the average window that gets put into a volume home in Australia is significantly worse than the windows you get anywhere else in Europe or America. And I think it's an exciting space. That move to 7 stars will mean that there will be some improvements to things around window supply chains in terms of the quality that's available and the cost of that quality, and that's a bit exciting.
What about UPVC window frames? great for durability and low maintenance. Pretty good thermal performers too. What are the downsides?
Combustibility, a bit like timber. You'll never see UPVC timber or fiberglass on an apartment because of the combustibility issues, for instance. So
they're pretty popular for single residential buildings, though.
Yeah, they are. And we're increasingly, there's a bit of local manufacture, and I believe that as Grady was saying, with the move towards 7 stars, there is that manufacturers are looking at ramping that up a bit too. So, which is a good thing, as exactly what he was saying in terms of the readiness of supply, and the price will no doubt come down. So, they're a pretty good option as well. Yeah, inherently quite thermally efficient. So, I mean, Elizabeth, I do agree. I don't tend to look at things like, oh, it's got to be double glazed or it's got to be thermal broken. I tend to look at the numbers because I'm a bit of a nerd like that. But the facts are, if you want to start getting really good windows, and especially in colder climates, if you want to control that condensation around the edges, especially, if you've got then timber window sills where that condensation can start to get into and cause problems. Yeah, the thermally broken or UPVC fiberglass or timber, they all have those benefits that, because we do see a lot of people looking for the double glazed, that's the thing they want. They want double glazed, and the cheapest double glazed is aluminium thermally unbroken. And you can actually get, if you just look at the numbers, there's this overlap of where the poorest performing double glazed windows are actually outperformed by the best performing single glazed windows. So, it is really good advice that, Elizabeth, you just look at those numbers. That's the key thing, because you may be actually paying for something that you think is great but doesn't perform that well.
One of our viewers has actually asked, is it always worth investing in double glazing to replace large single pane windows? And I know the answer to this, but I wonder what you guys think. I know what my answer would be.
I suppose that I kind of touched on it there. There's look at the performance, and as Grady and others were saying, like, if you can get that performance modelled, it's because there's often not just clear, simple answers to these things, because they are quite complex. But if you get it modelled and work with an assessor that'll help you, because some assessors they just want to do it quickly and tick that box, get the 6 or the 7 stars, and you're gone. Whereas others are happy to work with you and play with different options. So
use your energy efficiency rating as a design tool, not just as a checkbox. Yeah, absolutely. I think and the answer to that question from my point of view is different depending on whether you're doing a new build or a renovation. And for a new build, I think pretty much, depending on your climate, tropical climates are a bit different, but in temperate climates, pretty much it's a no-brainer to go with double glazing of some type. But if you're retrofitting an existing house that has single glazed windows, then that can be quite an expensive proposition. And there are plenty of things that you can do to improve the thermal performance of your windows without going that far. So curtains or thermal blinds that are either closely fitted or with pelmets to stop the convection current of air coming behind them. External sun shading to keep the summer sun off the windows, because as soon as it comes into the house, internal blinds and curtains are much less effective. And there are also secondary glazing options, which are kind of sort of like fitting a secondary pane of glass to your existing panes of window panes, or it's usually not glass, actually, it's usually some form of acrylic. But there are those options that do not deliver quite the same thermal benefits as double glazing, but are a lot better than single glazing and usually come in cheaper. So all things to consider, especially if you're on a really tight budget. Just replacing all your windows with double glazing is definitely not necessarily the best bang for buck when you're looking for a budget or cost-effective energy efficiency retrofit.
Yes,
that's what I reckon.
and just to add to that, that in terms of bang for buck, your living areas tend to be the biggest bang for buck. So if you're on a limited budget and you really want to try and lift the performance through some high efficiency glazing, but consider, and again, the NATA's rating can help you sort of as a design tool, but go for those living areas where you tend to be during the most of the day and using the most energy. You'll save the most energy by targeting those living area glazing components first, and then moving to the bedrooms. Unless you use your bedroom as a home office, that's a bit different. But if you use it for sleeping at night, shut the door and leave the single glazed or whatever it is, and you get your bang for your buck at your in your living areas.
Yeah, and one other thing with windows is thinking through natural ventilation, obviously. So how you can moderate the airflow through the house. And I guess it's also thinking about what's next to the, like how the air is going to enter the house. So whether you can put low ventilation that comes off garden areas would be cooler air than coming off a concrete deck, or that again, it depends on where in Australia you are.
Yeah, it's a good topic to bring up too, because we mentioned at the beginning that we'd be talking about breathability of building materials, and that really links into ventilation, draft proofing, air tightness, condensation and mold. It's a really big topic. We have touched on it a little bit in previous sessions, but basically as our homes are getting to be more airtight, as we're building them more airtight, which is a great thing, we also need to be aware of potential condensation problems. And so I mean, maybe one of you could give us a brief overview of how those things interact and how building material choice can help avoid problems.
Big topic.
Big topic, I know.
and really complex, isn't it? I mean, I'm happy to have a little crack at it. Yeah, there's, I suppose there's different parts where the condensation, for starters, the condensation can form and be problematic in different parts, and there's different solutions to that. So, if you quite common in cold places, especially, you'll see bathrooms because of the lots of moisture in there and the steam. You'll start to see mold growing on the walls and roof. So that's one form of condensation that's occurring inside, and the solution to that is generally if the moisture is getting trapped from inside, from the cooking, from the shower, from just being really
human occupants
tight, human
breathing.
occupants breathing, exactly. That's generally got to come down to ventilation. So there is obviously, as Jane was saying, windows are one way of ventilating, but they're not always the most reliable, because people often don't want to use them for various reasons: noise, smells, security. And if your house has been built particularly tight, which is a good thing, but it's not just about to steal a line from other people. It's not just about building tight, it's about ventilating right as well. And that's where mechanical ventilation is probably an option. So for instance, for that bathroom, if you've got mold growing in it, hopefully it's got an exhaust fan, but you can actually get really cheap and very effective continuously running exhaust fans now that run at a very low flow rate continuously, only drawing 5-8 watts. So not a lot, and that can often, depending how tight you build it, like not a passive house tight, but that can be enough to ventilate a sort of mass market well-sealed house just through leaving that exhaust fan in the bathroom on continuously. And that can solve many of those indoor air quality, condensation, mold issues. But then there's also the condensation that forms within the walls or within the ceiling cavity, and they tend to be a result of, they can be ventilation as well of those cavities, but yeah, that's where it becomes quite complex, and where you really need to work with generally with some local know-how about and good builders that know how to deal with your local environment to keep water out, to things like building with the old-fashioned foil wraps can be quite dangerous in most climate zones, and that's where there's a lot of now breathable wraps that can keep moisture out. They're like a Gore-Tex jacket. They can keep the rain out, but they let the water vapor through. And it's a really complex space, and I don't claim to be an expert, but it's one that you've got to be aware of. Some materials, if they're not, polystyrene is one of them. We talk a great insulator. A lot of builders would like to build with it in SIPs or whatever, but you do have that problem that it's not breathable, and moisture can get trapped on one side or the other and start to then condense within cavities and cause enormous trouble. So yeah, I've probably said enough because I don't know that much about it.
I think one of the things that the vapor permeable membranes are now compulsory in climate zones. I think it's 7, 8, 9 or so I think that will help us quite a lot now that we're not wrapping our houses up in foil. And I think that also I've started to move towards using those in the ceiling instead of under a roof instead of using a building blanket with a foil backed building blanket. So I think that it's something that and I know that the master builders are having a session on it this week, and I think it is something that builders are finally becoming much more aware of now. Yeah
absolutely. And David mentioned passive house before, which is capital P, capital H passive house, which does have a very, very stringent air tightness requirement. And those houses built to those standards do require mechanical ventilation, which can be very low energy use and almost always, or always, as far as I know, incorporate heat recovery.
Yeah,
which means that fresh air is continually coming into the house, but that the heat from the exhaust stale air is transferred to the incoming air, so that you don't lose all your heat as you do when in winter, that is, or cool in summer, as you do by opening a window. So not to say that you can't open a window in a passive house, but you don't have to in order to get fresh air. And there are mechanical ventilation with heat recovery systems that can be retrofitted. You don't have to have a passive house for it to be a good thing to have. There are ones that, even little paired ones, decentralized they're called, that can be fitted to existing houses to make some improvement in the CO2 levels, for example, and without opening windows. But that's a bit of a rabbit hole, maybe. Okay, where are we going next? So it's often said that one of the best things homeowners can do for sustainability, which we have actually touched on this topic a little bit, is to retain and renovate an existing house rather than building new, especially particularly now with the costs of new materials and the costs and availability issues. Where that's possible, of course, sometimes it doesn't make sense. What can we do when building to ensure that the materials we use are really valued and can be reused, ideally can be reused again and again?
Nice time.
Yep.
No, Jane, go.
No.
You go.
No, you go. I was actually just going to clarify, do you mean how can we build better so that we can reuse the materials again, or how can we better adapt existing buildings? Sorry. Or either.
Yeah, both, I guess. It's a question about the valuing the embodied energy in existing materials, and and a house that is already built is a huge pile of building materials that's not needing to be created new, so the value of that, and also what can we do for a new build or for any kind of renovations or extensions to ensure that those materials will have the longest life possible, or as many lives as possible?
Yeah. So one thing I've started to do is rename my demolition plans material resource plans. So really looking at what,
that's cool.
yeah. So what is there and how can it be used again? So yeah, I think it's just moving into the circular thinking space. And that's at the front end of a project, obviously dealing with an existing building. But then, you know, at the end, I know all of my schedules also start to talk about what the next phase for that particular material will be after the life of that particular project. But I think designing for deconstruction or designing for reassembly, it's just really important not to use too many glues, to try and use mechanical fixings where you can. I think a lot of contemporary building in Australia does rely a lot on adhesives, but cutting them out of the build is also really effective in cutting out a lot of chemicals and also a lot of plastics from the building as well. So there's lots of benefits from doing that. And yeah, I think I read a statistic that only 1% of building materials in Western Europe ever get reused in a new building. So it's definitely a new area, but I suppose it just makes sense to try and keep materials in as large panel sizes as you can. And I don't know, it's something I'm really looking forward to drilling down into as I move forward with my.
That's a terrifying statistic.
Yeah, I know.
Bad.
So it's just hard because, I mean, there's obviously all of the regulatory requirements for buildings, for building materials as well. So often regulations are continuing to outstrip. Yeah, it's just a tricky space, but it's something I'm really keen to embrace.
Yeah, I think Jane's just touched on something that I was going to mention, which is that I think one of the things that's important for people to be aware when they're wanting to think about using recycled materials is that there are challenges in doing that when you your builder needs to be confident that that the materials are fit for purpose and that they're going to comply with all of the current regulations, because they're warranting the work that they're doing. So it's really important, if you're wanting to use recycled materials, to talk early with the builder and maybe even select a builder on that basis. So it's the same with timber, actually. If you want to use some really unusual approaches to timber, for example, then you also, it's something else that you should discuss with the builder early on. But yeah, having materials that just that retain their integrity, that don't get mixed with other materials is the key to this. So for example, I tend to not recommend composite plastic timber decking products, for example, because two reasons. One is they're absolutely revolting underfoot because they get so hot, but the other is that that once you're done with them, or if you've got offcuts, or you know something happens and they need to be replaced, they just go in the bin because you've got contaminated plastic, so there's no further use for them. So you know, that's an example of something which is where two materials have been mixed together into a composite. So a composite should be a bit of a, generally speaking, it should be a bit of a sound some alarm bells for you, generally, if you see that word in building materials.
I'm going to jump in and plug a business called Revival Projects that's working out of Victoria. They're doing a lot of work in that recycling of building materials and trying to put them back into the site that they were taken from. So they're working with a lot of those inner city apartment developers. And although that structural member might not go back to being a structural member, it might be remilled and stripped down to a more aesthetic one. They're doing lots of work in that space, but they also have a really huge warehouse where they will store construction materials from your demolition for free for, I'm not sure how long that period of time is.
That's
And they
great.
can help you with the engineering and how to strip those materials and reuse them in the new build. So they work with architects and things, and they're really, really passionate about that. So I definitely recommend checking them out. They've done some really cool work. And I'm also going to jump back to the previous section about breathability and ventilation and talk about, just because there's a few questions that have popped up in the chat that I think are really important to address. Sorry. I guess the question is, can breathable materials replace the need for mechanical ventilation heat recovery units in well-sealed houses? I could say no and leave it at that, but I'll go into a bit more of an explanation. So there's a few different types of breathability and ventilation in our homes. So there's that vapor permeability, the breathability of our products to let that moisture through. There's the controlled ventilation that we love. That could be our windows. It could be our mechanical ventilation, so our exhaust fans or our HRV system in a passive house. And then there's that uncontrolled ventilation, which the average Australian home has a lot of, and that's all of the drafts and the gaps and the little bits and pieces where it's not sealed up very well. As we start to build better and reduce that unwanted ventilation, the mechanical ventilation becomes more and more important, or our windows and our exhaust fans and things. So I think it's really important to note that just because maybe we're using hempcrete and we've got all hempcrete walls, you have to still have that ventilation. So your exhaust fan or your HRV, it's really complicated how that all works. But you know, your average sort of Victorian home, I tend to be more knowledgeable about Victorian things, just that's the area that I have access to the knowledge of. You know, has an air tightness somewhere up towards the 20 air changes per hour. That's an existing home built prior to construction codes, majority of the housing in Victoria. Our newer houses that we're seeing going up now, they should be achieving around about 10 air changes per hour. We have seen new homes that are achieving significantly higher than that, and that's not great. We're doing lots of work in that space at the moment. And your passive house, they'll have sort of, you know, less than one. They'll have less than half an air change per hour. So they're really, really, really airtight, and they need that mechanical ventilation. If you think your home's getting a bit stuffy, you know, the air's a bit stale, it probably wouldn't hurt to get an air tightness test done. Hit up ATMA, the Air Tightness Testing and Measurement Association of Australia. They'll have a big list of accredited assessors in your area. Get your home tested. That tester will be able to tell you where all of the leaks are. And they'll also be able to tell you if, for whatever reason, your home is really, really airtight, that you probably should look into some form of mechanical ventilation. But in terms of reducing energy use in your home, trying to get rid of all of that uncontrolled ventilation through the gaps and the cracks and the drafts is a really, really good first step. You just have to be really careful because you can overdo it and contribute to a more unhealthy building. So it's a bit of a fine line, and it's probably good to engage a professional if you're doing lots and lots of draft sealing.
Thanks very much, Grady, for that very
probably a bit preachy, I'm sorry.
No, it's a very detailed summary. That's really good. I mean, it's a tricky balancing act between airtightness and draft proofing and airtightness, which are obviously good things, and ventilation and mold prevention, condensation and mold prevention, which is the flip side of it. So thanks for that. We kind of interrupted our broadcast on recycled materials and deconstructible design to get back to that. Does anybody have anything else to add on that topic?
Something I will just say is that some of this stuff is really important to have documented in your working drawings. And so, the principle of screw, not glue, for example, those sorts of things. There's a whole bunch of those things that it's really important for you to work with your, with whoever's doing the documentation for your building, if you're doing a reno or a new build, to try to document those principles and put them into practice in terms of the construction detailing, for example, so that you're just not leaving it to chance. Because otherwise those sorts of things, they really do require your active involvement in the process.
There's a terrific house that we profiled in Sanctuary a few years back now called the Recyclable House in Victoria, where the designer, who was also the homeowner, set out to see how recyclable they could make the house. And the answer equals that it wasn't very hard if you set out to do that, and screw not glue, and avoid composite materials, and avoid creating composite materials as well. For example, by sticking tiles with adhesive to a substrate. It did make the bathrooms quite challenging, I believe, because you still need a waterproof layer, of course, in a bathroom. But it's a really interesting read. And I believe James put the link to that in the chat already. Yes, that's right. He's just posted it again. And also, getting back to the previous conversation, there's a link now in the chat about that links to an article by Jenny Edwards from a while ago, from Sanctuary a while ago, on at what level of airtightness you really should consider mechanical ventilation, or should maybe consider it, and at what level you really need it, and at what level you probably don't need it. So that's that could be good information for people interested in that topic. We are getting to the end of our time, folks, amazingly. I wanted to just ask, actually, two more things before I get into my final question. I just wanted to touch on building in bushfire-prone areas. What extra considerations are there when choosing materials for higher BAL ratings?
Generally, the main consideration is around designing so that sparks can't infiltrate or build up around the house. So no small gaps and no areas of entrapment. So that does mean you can use timber in certain moderate level BAL situations, but you do need to design it in such a way that it won't be subject to those spark build-ups.
Okay.
But yeah, you do need blinds to windows, which generally have to be metal when it starts getting up there. So it certainly just depends on the BAL rating, and it is a lot about the actual design outcome rather than just the materials per se.
Yeah, it's definitely a combination of design and material choice.
Yeah.
Yep. And there are, I think what some people don't understand is that even, I might be wrong about that, but certainly towards the higher BAL ratings, it is possible. There are species of timber that it is possible to use still, depending on the way that they're used. So don't think that you need to build your house as a concrete bunker necessarily just to make it fireproof rather. So we are actually running a series as part of Sustainable House Day next month, a series of seminars on retrofitting in bushfire-prone areas, which will cover a lot of these topics. So if you're particularly interested if this applies to you and you're interested, please check out the details of those sessions on the Sustainable House Day website and consider booking in. But yeah, the quick takeaway is that the standard for building in bushfire-prone areas does list both design requirements and materials that are appropriately non-combustible or low combustible for different BAL levels. So it'll probably make your build more expensive, but good to know about things like that from the outset. And so finally, I'd love to ask you all, what's your top tip or secret strategy for choosing the best material for a particular job? Particularly the architect amongst us.
Can I say choose what gives you the best feeling? What material makes you happiest in your house? Like everything else aside, picking hempcrete because it's breathable and, you know, renewable, blah, blah, blah. If you don't like the aesthetic, you know,
You're not going
it's
to
something that
get joy from
really
your house.
you love. Yeah, it has to bring you joy.
Hmm.
Yeah, that's a
Very
great point.
good
We
point.
haven't really talked too much about that tonight. Aim for delight
Hmm.
as well as everything else.
Mm.
Thanks, Grady.
Left us.
Next.
I've just got a sort of an appraisal system, I guess. So I think I touched on it at the start. It's like, do we actually need the material? Can it be salvaged? If the answer, I guess, and then if you really do need to find a new material, finding a responsible material. So checking the VOC, checking the certifications, the embodied cut. It's a bit of a straightforward checklist, but I do have that so that it just helps me put parameters around the selection of each material. Bit boring, but at least each material is considered from a variety of different options, and I'll have to triple check that delight is definitely on there as well. yeah, I mean, architects are always thinking about that too.
Yeah.
And,
I have
building a house that delights is a great way to make sure that that house will have a longer life as well, which leads directly back into, you know, a better outcome from an environmental point of view for all those materials that you choose in your delightful house. If they stay there longer.
Yeah. Yes,
Elizabeth,
because if we love something, we look after it more. And so I think that's something we really haven't talked very much about, but maintenance and longevity of materials is a really critical part of the material selection.
Mm-hmm.
I have a values, like a little values kind of exercise that I get my clients to go through. So and I give them I allocate them a number of ticks, and I say, you know, you're building anything from a castle to a cubby, whatever, but you've got this number of ticks. And then I have a range of different criteria based around many of the things that we've talked about today, including your sort of aesthetic and, you know, that kind of thing. And people have to allocate their ticks. And so it usually, often even like if I'm working with a couple, there'll spark some discussion and debate between them.
Ticks will be different.
So I try to respond to what my clients are have as their priorities, while also sharing with them, I guess, what my priorities are and what my concerns might be, and the information that that I feel that they need to have to make informed decisions. So yeah, I think it's for my work, it's about it's very site specific, it's very context specific, it's very client specific.
Yeah, so it's not like you have a particular, well, even if you do have particular favorite materials, that's not the point really.
Yeah,
is it?
yeah. And sometimes this comes back to what I said at the beginning. You know, sometimes, you know, I was doing a project helping out a friend who needed to replace her front windows, and she's in a heritage area, and so she needed those windows to be timber. And she's a single mum. She's got not much money, and you know, she had the choice between Vic Ash, Eucalyptus regnans, you know, flogged by Vic forests, you know, windows, or Accoya, which was going to cost her a hell of a lot more. And it was a no-brainer, really. Like, you know, for her, it wasn't. It really, she went for the Eucalyptus regnans because, you know, because that was her capacity. And really, you know, there's no point in tying yourself in knots over these things, really. People contribute to the world in many different ways, and I think we all have to be quite gentle with ourselves as well as with other people about the choices that we make about materials.
Your thoughts, David?
Oh, look, I probably haven't got anything to add, and in fact, I think Elizabeth's point there would be a great way to sum it up. Is you know, don't give yourself a hard time. All of these materials, they all have pros and cons, and I think, as Elizabeth said as well at the start, like there's no perfect material for any given situation. So yeah, what everyone else said basically, is if it makes you happy, if it ticks your values, because we're all different people, we have different values, we have different perspectives, and we have different means as well. So yeah, you know, I don't go, you know, I have my own values, and I know the materials I'd like to use because they fit my values, but I wouldn't put that on anyone else because they will be different and they might have different means. And so I think it's a really good point that you made, Elizabeth, is don't beat yourself up over it. The choices are huge. They're really complex. There's no perfect choice here. So yeah, do what you can, and certainly worth researching and thinking about these things. And yeah, Grady made a great point at the start. Make sure it makes you happy, make sure it brings you joy, because you know, you're going to spend a lot of time in this place, hopefully.
I'm just responding to something in the chat. Sorry, lost my train of thought.
Double C, Anna.
Double C, sorry. Yep, I do know that. Talking at the same time. There we go. Yeah, okay, thanks. Sorry, I've completely lost my my mojo now. It's 2 hours of trying to follow 4 or 5 different threads at the same time. Listen, that is all the time we have tonight. Thank you so much to all of you, David, Elizabeth, Grady, and Jane, for joining me tonight. I know it's a big ask, and we really appreciate you sharing your time and expertise. And thank you to all of our attendees for tuning into this Sustainable House Day session. We were overwhelmed with questions. I'm really sorry that we couldn't get to more of them, but I hope that we covered enough to answer some of your questions and maybe get you thinking about some things that you hadn't thought of to do with building materials and choice of building materials. There is one more session in this series next week, so please visit the Sustainable House Day website for the details and to register. It's on energy systems, as well as checking out our other events coming up. You can buy tickets for individual events or discounted series passes. And we've also introduced an annual pass for all Sustainable House Day events, which means each event costs around $3 or so. Don't forget, members of Renew receive free or discounted tickets, and we always have an allocation of free places for anyone experiencing financial difficulty. And a quick plug from me for Sanctuary. If you're not already a subscriber, or if you have someone in your life who just love reading about sustainable design 4 times a year and admiring beautiful photos of it, we'd love it if you jump online at sanctuary.renew.org.au and sign up or gift a subscription. Thank you again, everybody, and good night.